All right, y'all, so going to the camera. All right, so this will be the finishing parts of Unit 2B. And we're still doing our problem solving. All right, so the main thing I wanted to do was introduce the metric system to you. So we're going to look at the metric system. So in the metric system, instead of having units like yards, feet, inches, they use meters and centimeters and terms like that, millimeters and stuff. So I'm going to give you the basic units, and then we'll look at the prefixes, because in a metric system, it's those prefixes that mean a lot, okay? So their basic units are going to be meter, and the meter deals with length. Kilogram, or gram. All right, let me let one in. So that was Ashley Ghoston. All righty. Seconds, and that's the same in the English system and in the metric. That'd be time. Oh, y'all forgot to put it up here for the kilogram and gram. They measure mass, and mass is basically weight. And then the basic unit, the liter, and that's the basic unit, would be volume. Okay, so what we're going to do, we're going to show you what these abbreviations mean in the metric system. So I'm just going to take one of these basic units, the meter, and I'm going to set that in the, that's going to be the middle of my chart we're about to create, okay? All right, so your meter is your basic unit. I'm going to look at the smaller values first, and then we'll look at the larger values. So 1/10 of a meter. All right, let me catch one more, y'all. So that's this. See. All right, so 1/10 of a meter is what we call a decimeter. So that is 1/10 of a meter, or if you're writing it with exponents, that would be 10 to the negative first. So negative exponents go towards decimal numbers. Positive exponents will deal with numbers greater than 1, okay? All right, the next one would be the centimeter. And that is 1/100th of a meter, or you can write that as 10 to the negative second power. All right, next is a millimeter. Y'all, that is 1/1000th, or 10 to the negative third. Now, y'all seen these if you've ever seen a meter stick. Most of them are broke down into centimeters, but the little bitty notches are for millimeters on those, okay? All right, now we go to what we call a micrometer. No, that is 1/1,000,000th. So that would be 1/1,000,000, or 10⁻⁶. So after you get to the millimeters, they start jumping by powers of 3 on those exponents, or by every 1,000, okay? After micrometers, we got nanometers. That is 1/1,000,000th. So that would be 1/1 with 9 zeros, or 10⁻⁹. So they're only going to go one more, and that is a picometer. And y'all, picometer is 1/1,000,000th. So that would be a 1 with 12 zeros behind it. Or 10⁻⁻12. So over here, I'm going to give you the symbol for decimeter, would be a D for deci. And then you would write a M after that for the meter. Centi is a C. Milli uses a little M. Micro is the Greek symbol, mu, or they will use a MC. So medical fields, they'll use that MC, but in Greek, they use the mu symbol. Nano is a little N, and then pico is a little P. So y'all, that's my smaller prefixes. Now I'm going to go upward. So right above a meter, we got what we call a decameter. Decameter would be 10 meters, or 10⁻⁻. So everything going up is now going to have positive exponents, okay? Above deca, we have a hectometer. Hecto means 100, or 10⁻². Next one you are familiar with, that is a kilometer. Prefix kilo means 1,000, or 10⁻⁵. All right, next we got mega. So megameter. Mega means 1,000,000. So that'd be a 1 with 6 zeros, or 10⁻⁶. So y'all are familiar with mega on your megabytes and stuff like that. That means it's 1,000,000 bytes. Giga. So a gigameter, giga is a billion. So 1 with 9 zeros, or 10⁻⁹. So that means a gigabyte is 1 billion bytes, okay? So that's why you like the G bytes better than you like the megabytes. And then the biggest one that we'll look at is a tera. So a terameter would be a trillion. So that's a 1 with 12 zeros, or 10 to the 12th. That's why them supercomputers, if they say they got a terabyte of storage capacity, that means they got a trillion bytes of memory on those, okay? So let's go this way and look at these abbreviations. So a decameter, it can't use the D because that's already being used by the decimeter. So decameter uses a DA. And it's the only one you're going to have with 2 letters for its name, okay? Hectometer would be a H. Kilo is a K. Mega is a capital M because the small m was already used by the millimeters. So they use a capital M for the mega. Giga is a capital G. And then tera is a capital T. And y'all, these are such large amounts, they went with the capital letters on those other than the smaller case, okay? So y'all seen this chart before, right? So I'm going to show you some examples. They're going to ask us about these. So on this one, I'm just going to convert 2,759 cm, which is centimeters. We're going to turn those into meters. All right, so just like I was doing my problems yesterday, I'm going to write that 2,759 centimeters. And then I'm going to make my little T chart. So we need to cross these centimeters out and turn them into meters. So let me turn over my page. So we're going from centimeters to meters. Centimeters are right here, and we're going to meters. Well, this says that a centimeter is 1/100th of a meter. So what that's telling me is that 1 meter would equal 100 centimeters. Okay, so a decimeter would be 10 decimeters for a meter, 100 centimeters to make a meter, 1,000 millimeters to make a meter. Okay, so anything down here takes that many to make a meter. So I'm going to use my conversion. 1 meter equals 100 centimeters. Now remember, I've got to cancel the centimeters out. So the 100 centimeters has to go to the bottom so I can cancel them centimeters out. And we said that 100 centimeters equaled 1 meter. So y'all, we would cancel the centimeters out. They wanted me to put my answer in meters. That's what I got left. So really on this one, all we got to do is divide 2,759 by the 100. Remember, since it's on the bottom, you got to divide by the number. If it's on top, then you would multiply. So y'all, if I divide that, I end up with 27.59 meters. And that makes sense because remember, meters, since they're a bigger measurement than a centimeter, that answer better be a smaller number than you started with. All right, y'all good on that? So now we'll look at a little bit of temperature, and then I'm going to sort of go over some of the problems in your homework. So there's 2 main temperatures that y'all are familiar with, and then I'm actually going to introduce you to the 3rd one. So we're most familiar with the Fahrenheit. Right, Fahrenheit mostly used in the United States. So in Fahrenheit, we know water freezes at 32 degrees. We know water boils at what is it, 212 or something like that. All right. The other scale you are familiar with is the Celsius. Celsius is more probably European and stuff. So they got different freezing points and boiling points. So in Celsius, water freezes at 0 degrees and it boils at 100 degrees. Okay, so Celsius went off the scale and they went off the 2 points on the water where it froze. They made that their 0. And where it boiled at and turned into a steam, they made that their boiling point. So anybody know the third temperature scale? So watch
Kelvin.
this. Oh, there it is, the Kelvin. And what the Kelvin does, they based their scale off of what they call absolute freezing, which is pretty much a temperature that all molecules would be frozen. They wouldn't have any movement. And absolute 0 is the coldest possible 0 we can live with. So on the Kelvin scale, their 0 point is equal to, so let me write that down. So 0 Kelvin equals negative 273.15 degrees Celsius. So they used this as their 0 for the Kelvin scale, and then their scale is calibrated in the same ratio as the Celsius scale, okay? All right, so we're not going to kill you much about that, but there are a few problems where you got to sort of play with them and convert those. So let me see. So we're going to look at temperature conversions. So y'all write these down because I'm not sure these are going to be on that. I don't think these are on that unit helper sheet I had, okay? So the first thing, I'm going to turn Celsius to Fahrenheit. To convert from a Celsius temperature to Fahrenheit, you're going to have F equals 1.8 times the Celsius temperature plus 32. And they got to 1.8 from the 9/5. So you might have seen it in fraction form. F equals 9 divided by 5 times Celsius plus 32. But really, it's probably easier to work with these decimals on those, okay? All right, what if we want to go from Fahrenheit to Celsius? So I know the Fahrenheit temperature, but I want to convert it to Celsius. My formula will be C equals F minus 32 divided by 1.8. Now, y'all, here's the thing. If you work this formula right here on your calculator, you need to put the top of this in parentheses before you divide it by that 1.8, okay? Calculator won't know that your problem's set up like this until you put parentheses around that top. So if I want to go, say, Celsius to Kelvin, I would have K equals the Celsius temperature plus 273.15. Just remember, that's what we was subtracting to get that absolute zero, okay? And then how about Kelvin to Celsius? That would be C equals the Kelvin temperature minus the 273.15. So notice, to get Kelvin, you add the 273 to the Celsius temperature. To get Celsius, you subtract 273.15 from its Kelvin temperature. All righty, so let me go through some of them homework problems y'all were probably looking at and might have been having issues with. So have any of y'all started on that homework?
No.
For 2 ABC?
Yes, I finished it.
Oh, wow, so you actually figured out the one with the wires around the bar.
I think I got that one wrong.
So that was a very tricky problem, I'm not gonna lie. So I might actually start out with that one. So that was like number 18 on y'all's homework. So let me get this challenging one out of the way, okay? So I'm gonna do problem 18 first, and then I'll go back and work my way through, okay? So let me put this up here so that y'all can see what we got. So this problem says, suppose that 8 turns of wire are wrapped around a pipe with a length of 60 inches. So notice I drew a pipe and I made it 60 inches long and a circumference of 4 inches. So the circumference is the circle part, and they're telling me that this is 4 inches around right here, okay? And they're telling me so that the wire reaches from the bottom of the pipe to the top. So they're wrapping this wire around this pipe. So let me show you. I made me a little visual on this. I cut a little toilet paper thing to make y'all visual. So y'all see how I got my wire is wrapped around it, and it's wrapped all the way around that pipe, and it goes all the way from the top to the bottom on this, right? So they're wrapping it around. So then they want to know the length of that wire that we wrapped around this pipe. So look here what they said. Picture cutting the pipe along its length and pressing it flat. So say I come down, I cut my pipe. I'm going to take that and lay it flat. So they want us to get the length of this wire that's going around here, right? But do y'all notice something? Oh, let me find it. Oh, I used to have a ruler, but all right. So let me show you what they think. What they want you to realize on this is that there you got a line going across here. What if you came in and filled these lines in right here? What does this look like?
Coil.
And notice, if you came in and drew lines across this, so say I come in, I drew these lines across here from the ends of these wires going across here. What do I got a bunch of?
Triangles.
I got a bunch of triangles. Okay, so I got a bunch of triangles, and these corners make what we call right triangles. So we got a nice little formula that we can use for right triangles. So I'm gonna come back. So let me draw one of my triangles going across here. And then remember, that's going to make a bunch of triangles that have the same dimensions, okay? So here's my triangle. So let's think what was the big parts of this. My pipe was 60 long. It was, what did I say, 4 inches for my circumference. So that's going around it. And we did 8 turns of wire.
For some reason, my screen froze.
All right, so let me stop that share and reshare it.
Okay.
So usually that helps, so we'll see.
Okay.
Right, are you seeing my paper now?
Now I am.
Am I moving a hand under it? You seeing that?
Yeah, gotcha.
Okay, so you're good to go.
Uh-huh.
Okay. So we made a whole lot of triangles on that picture I showed y'all. So let me let one in real quick. Oh, it keeps going away. Maybe they're getting knocked off. So the big part of this was that we had 8 turns of wire coming around this thing. 8 wires going around it. All right, so what we got to figure out is how long is that side, which is these little sides right in here. How long is all of these sides going to be? And then how long was that side? So now this one keeps getting knocked out and in, I think.
Yeah, you know.
So notice this one side, this long side, that was the round part when I took it apart, right?
Right.
And they told me how long that round part was. They said, hey, that thing was what, 4 inches. So we know that that long side right there is 4 inches. So now we got to figure out how long this side is. Well, guess what? This thing is 60 inches long, right?
Mm-hmm.
So to get that other side, I'm going to take that 60 and divide by those 8 turns. So you would have had 8 little notches along this if I'd have drawn 8 turns on it. So take the 60, which is that whole side, divide by 8. So let's see what that's going to give us. So 60 divided by 8, I'm getting 7.5. So that means these ends are all 7.5 on each one of my triangles. All right, so remember, this is a right triangle. So do any of y'all remember a nice little formula that I can use with my triangles? So I'm going to tell you, it starts with a P. So I'm going to get y'all, how about y'all remember this now? Pythagorean theory, right?
Yeah, the dust ain't came off yet.
Do what now?
The dust ain't came off my mind on this one.
Mm-hmm. So y'all should have remembered a formula that it says, well, A squared plus B squared equals C squared, right? So the longest side of this triangle is always your C. The other two sides are A and B, and it don't matter which one you make A and which one you make B. So what we would do, we would come down and take that 7.5, square that, plus our B squared would be the 4. So we would do our 4 and square that. That's going to equal our C squared. All right, so I'm gonna use a calculator to square this stuff. So let me show you on my other calculator how you would square those. So I'm gonna share my calculator. So I had 7.5 squared. So you can put it in parentheses if you want to, or you can just do 7.5. And to square it, you can just hit this X2 button on the left side. That squares them. So see how it took my 7.5, it's going to square it. So when I hit enter, that gives me 56.25. Now I had 4 squared, so I'm going to take my 4. I'm going to hit the X squared button to square it. 4 squared would be 4 times 4, which is 16. That's going to equal our C squared. So now let me go back to the writing pad. Yeah, y'all probably slept since y'all did all these fun problems like this. So now, since you got both of these things over here, we're going to add them together because they're on the same side. So you're going to do 56.25 plus 16. That's going to give me 72.25. That's going to equal our C squared. All right, my last step would be to take square roots of both sides. Because remember, to turn a C squared into a C, you take the square root of it. So you come in and do the square root to both sides. So square root of C squared will give y'all your C. On the calculator to do that one, let me share that screen. All right, so to do a square root on the calculator, over here on the left side where that X squared button was, right above it, you should see a blue radical. That's for square roots. So since it's blue, we got to hit the blue second button first, and then go hit that X squared key, and it brings up the radical. Then we put in our 72.25 and enter. So notice that gave me 8.5. So let's go back to the pad. So now think about this. We know now that that wire cutting right across through here was 8.5 inches long. So my question is, what is the length of the entire wire? So y'all guess what you're going to do? You're going to take that piece of wire we just found to be 8.5 inches. And you're going to multiply that by how many turns did I use?
8.
And they gave us that. That was the 8. There you go. So let's multiply that 8.5 times those 8 turns. So it looks like I'm getting 68. So that means that total wire was 68 inches long. So that was the sort of challenging problem. Now, you don't have to memorize that Pythagorean theorem, but just keep this sheet I just made for y'all. as a guide to do that problem, okay? So the differences they're going to give you, your bar might not be 60 inches long, and it might not be 4 inches around for your circumference. And then they might change your terms from 8 to 7, 6, or something like that. So remember, you're going to know two of your sides. That's going to be your circumference. And then this side was the 60 divided by how many turns I had, okay? And then right here, square both of those, add them together. Once you got them added together, take the square root, and that'll give you the length of each little wire per triangle. So yeah, that is a good one, right?
Mhm.
And they like letting y'all see that one in the future, if you know what I mean. All right, so let me look at some of these homework questions. So first one asked me, what does the word of mean? So it's divide by, in addition to, or multiply by.
Multiply.
And definitely multiply. So this one asked me, well, how much will a person pay for 9.7 pounds of bananas at a price of $1.66 per pound? And y'all, I'll show you an easy way to do that. They're telling me the price is $1.66 per pound. So my pound, I can make that a LB down here. Right? So remember, I'm looking for how much they're going to pay. So my end answer has got to be money. It can't have these pounds in it, okay? But they gave us 9.7 pounds. So if I multiply by the 9.7 pounds, notice those pounds are going to cancel. I'll be left with money. Now notice they say round to the nearest cents. So that means 2 decimal places. So 166 per pound. You bought 9.7 pounds, they said. So I end up with 16.102. So that'll be 16.10. And remember, we canceled the pounds. So the only unit left is the dollars. So they'll make you come over here when you put in your answer. And you have to click those dollars there, okay? All righty, so let me see. So I had this one pinked out. If a person's paid $480 for 26 hours of work, what is the person's hourly wage? Okay, so hourly wage is going to be something like dollars per hour, right?
Mhm.
Because dollars would be my pay, hours would be my time, but they're looking for me to have something in dollars per hour. So they're giving me the 480 right here in dollars. And remember, since it's per hour, that means my hours got to be on the bottom. And they told me this one worked what? 26 hours. So basically, you're going to take the 480 that you got paid, divide by the 26 hours that you did work, and that should give us a number. And notice once again, round 2 decimal places. So on that one, I would do the 480 divided by 26, and I'm getting the 18.461. So I'm going to make that a 18.46. And that would be what? Dollars per hour.
Mhm.
All righty, so let me move this down just a little bit to see this bottom one, these two right here. So this one says, your car gets 26 miles per gallon. How much does it cost to drive 420 miles when gas costs $2.90 per gallon? So what I did on that one, I took my 420 miles that I drove. So I'm going to take that 420 miles. And I know I'm getting 26 miles per gallon. So watch this. Which means you would divide that, right? So you're getting 26 miles per gallon. So you got 26 miles. Since the miles is on bottom this time, per gallon means the gallon goes up to the top. So watch, the miles are going to cancel. At the moment, I'm in gallons, right?
Mhm.
I'm looking for the total price. So if I'm looking for price, I need something that's going to end up in dollars. So here's the last conversion I got to worry about. It says $2.90 per gallon. So remember, per means you're dividing by the gallons. I need the gallons to cancel out. So my gallons will go to the bottom. And that 290 will go to the top. Now I'm just showing you how it looks like when you do this unit analysis. But y'all, you're going to, if you was to figure this out, you would what? Take the 420 divided by the 26. That would tell you how many gallons of gas you used. And then you would multiply that answer by how much it costs per gallon. So this is just showing you how those units really do cancel out. And you're ending up with the only unit left is the money we had, okay? So let's multiply the top first. So on top, I got 420 times 2.90. That's giving me 1,218. I'm then going to divide that by the 26. And I'm ending up with 46.846. They want me to round to the nearest cent, which means 2 decimal places. So I'm going to get 46. So let's see, 846 would round up to what, a 85. Okay, so this is officially how you're getting all the units to cancel and end up with money. I mean, like I said, that stuff y'all probably did in your head before. So some of y'all must have done something similar to this. Y'all done got these problems right? All right, we're going to turn 21 feet into inches. So I got 21 feet I'm starting with. Oh, and what's nice, we got a conversion we can use from feet to inches. For every 1 foot, I know that is how many inches?
12.
Well, there you go. My feet cancel. I'm going to be left with inches. So let's see, 21 times 12 is 252 inches. And you always expect bigger numbers when you go from feet to inches, okay? You know, these really ain't too bad. It's just sort of figuring out how you would do them. So right here, evaluate the following expression. So I sort of showed y'all this the other day. They want me to figure out all 4 of these. So let's see, the division, I'll show you how to do them. When you're multiplying, since these bases match up, when you multiply, you're just going to add the exponents. So since those match, we're going to have 10, 7 plus 2 gives me 9. So add exponents on that one. Well, B is the same thing. Those 10s match. So that means this is going to be a 10. So what are we going to do? We're going to add those exponents. So 4 plus a negative 2 is 4 minus 2, which would give me a 2. Now let me show you how to add those exponents on the calculator. Whoops, let me stop that share and share the calculator. All right, so I just wanted y'all to see, since that was a 4 plus a negative 2, I would go 4 plus, for negative numbers, you got to use this negative down here on the very bottom by the enter button, the negative in parentheses. So hit that negative and then put your 2. So watch, 4 plus a negative 2 gives me 2. So y'all watch this. If you did 4 plus, and say you use that subtraction key for your negative, watch what this calculator is going to do. It says error syntax. So if you go down to that number 2 where it says go to and hit enter, it's blinking on that negative. I can't use the subtraction, so I would have to put the 1 into parentheses to fix it and then get my answer. So negative numbers use the negative in those parentheses. All right, when you're dividing and you got the same base, instead of adding exponents, you're going to subtract the exponents. So this will be 10 because that's what's common. And then 9 minus 3 would give you 6. And then on the last one, you're dividing. So here you're going to subtract exponents again. So that's going to be a 10. So 8 minus a negative 4. So it's always just top minus the bottom. So y'all, look, when you subtract a negative number, that really becomes a positive, and 8 plus 4 would make that a 12. So that would give me 10 to the 12th. So on that one, when you do, let's go back to the calculator real quick. So on that one, I had 8 minus negative 4. So I would do 8 minus would be the subtraction key. And then I would do my negative 4. And you can see how the calculator sort of makes the negative numbers. It makes that negative a little higher and smaller than it does for the subtraction. Watch this. When we do that, we get our positive 12 like we said. Okay, so that's what was going on with those. So let me see what we got next. All right, so I did one the other day with the shampoo and which one was the better deal. So let's go back. I did money conversions. We just did the pipe. So let me do one like number 19. So let me read 19 and then we'll write down the main gist of this problem here. So number 19 says, you are considering buying 12 gold coins that look alike, but you have been told that one of them is a heavy counterfeit. How can we find the heavy coin, which is the counterfeit, in 3 weighings on a balanced scale? So I got 12 coins. Now I get 3 weighings, so 3 weighings to find that heavy coin. So y'all, I'm gonna show you what I sort of figured out. Now, there's probably more than one way to do this. But I'm gonna show you a trick I did to this. Now, remember, a balance scale is one of those that's got what, a tray on both sides and got a little meter in the middle that balances out when you got both sides equal.
Mhm.
So let me show you a little trick on this. I took the first 4 and the second 4 and weighed those. I put 4 queens on each side. So if these are equal, then I know that the heavy coin is not going to be in either one of these, and it's going to be in the 4 that I didn't weigh, right?
Right.
If I weigh them and one side is heavier than the other, then I know that side would contain the heavy coin, right?
Hmm.
So either way, I can narrow it down to some of these, to 4 of these. By just doing one weighing, I can narrow it down to 4. So now I got 4 coins. I'm on my second scaling. What I would do to that one, I would probably just do 2 on one side, 2 on the other side. One of them 2 sides will be heavier at that point. Y'all with me?
Hmm.
All right, so now I know that one of these 2 sides is heavier. I'm down to 2 coins. Well, guess what? I can put 1 on each scale. Whichever side comes down, I know is my heavy coin. So some of these little problems are sort of designed to try to make you think rationally, logically, and stuff. Okay. So did y'all come up with different ways of doing that one, or haven't messed with it yet?
Haven't messed with it yet.
So I don't know if they're all giving us 12 coins. I don't, if someone done it, I don't know. It might, sometimes they might use like 16 coins, 8 coins. It might be a little different, okay? So y'all, I think between Monday and today, I think we pretty much hit most of them problems that you're going to see on this homework. So do y'all have any specific questions y'all got questions on?
I have a question about one of the
Okay.
homework questions on number, I think it's 15.
15. Oh, so mine said 15 was about monthly rent.
Yes.
All righty, so let me find my sheets on that one. All right, so we're going to have to work that in from scratch. So let me get my sheet ready for us. And let's go back to my camera. So I'm going to share that screen. And this one's sort of using that currency stuff, okay? So they're telling me the monthly rent on a 110 square meter apartment in Monte Carlo is 1,400 euros. Then they're telling me the monthly rent on a 300 square foot. So notice this is using square feet. Apartment in Santa Fe. So Santa Fe, New Mexico is 750 American dollars. which apartment is less expensive? So which is less expensive? So what I'm going to do is figure out the price of the first one in euros per meters. We'll figure out the price of the second one in dollars per square feet. But eventually we're going to have to do a little converting on this one, okay? So I'm trying to see. Now on this problem, I just wanted y'all to see at the bottom, they sort of give you the a table with money on it. And we're looking at euros and what's ours, American, okay? So I'll be playing with that chart that's sort of like on the sheet I gave y'all. All right, so let me get my info that I need on this one. Alrighty, so calculator, we'll probably need a calculator for this one. So let's take that 1,400 euros. So that was a total price. I'm wanting to find the price per square meter. So I'm gonna take that and divide by the 110 square meters. Now, one of these you're going to have to convert either from meters to feet or feet to meters, okay? I'm probably going to do the converting up here and get everything in feet like my American one, okay? So we're going to have to convert from these square meters into square feet. And we're also going to have to turn these euros into American dollars. Or you can figure out this in euros per square meter and convert the Santa Fe stuff into euros per square meter. So we know that 1 meter on our chart equals 3.28 feet. But we're dealing with square meters and square feet. So we need to square both sides. So 1 square meter. So we got to square to 3.28. That's going to give us 10.7584 square feet. Okay, because most of these charts give us this conversion, but they don't give us the square feet. So you sort of got to figure that out by squaring both of those. So now I can come over here. Here's my square meter. So 1 square meter was equal to 10.7584 feet squared. All right, so I'm in feet squared like my Santa Fe stuff is going to be. Now I need to go from euro to American money. So on that, they're giving me euros. Okay, so the American dollars per foreign, I know the foreign, so the exchange rate will be the 1.058. So let's see. So where am I at? I'm gonna cancel this euro and make it into dollars now, because we just canceled out those square meters, okay? So for every 1 euro, that is worth 1.058 American dollars. So notice now I got my euros to cancel. So when I figure this out, it'll give me my price in dollars per square foot. All right, so everything on top gets multiplied. So you would have 1,400 times 1.058. That's going to give you 1481.2. we're going to divide that by everything on the bottom, which is 110 times 10.7584. That's going to give me 1183.4. So now I'm finally going to divide that. So 1481.2 divided by the 1183.4 equals 1.25. That means we're paying $1.25 per square foot. Oh, y'all, something on my exchange rate ain't doing right on that. Let me look. I might be having y'all do too much on that. Let me think. All right, so let me do that a different way. Let's just do it. I'm gonna take that 1,400, divide by 110, and that'll give me the price in euros per square meter. So 12.727, I'll make that 12.73 euros per square meter. All right, so I'm going to mess with the American one real quick. I'm going to take that $750 and divide by the 300 square feet. All right, so 750 divided by 300. So these are sort of small apartments, right? I'm getting 2.5 dollars per square feet. But remember, feet are nowhere near the size of meters, okay? Oh, and they told me you can, so y'all can actually click on the homework and it'll have the conversions on it. There's like a link you click in. Oh, yeah, I think I was doing it the way I needed, y'all. This is what, 2.5? What is that in money? That would be 2.50 per square foot. Up here, I figured out the Monte Carlo was what, 125 per square foot. So if you converted all this, you would still get these amounts. So I'm going to say Monte Carlo is 125 a square foot. This was New Mexico or Santa Fe. And we said that was 250 a square foot. So definitely the better deal would be the Monte Carlo. So I guess I didn't actually have to do this because I had worked it all up here. I just needed to figure out that Santa Fe one right here. And since I did all my conversions up here, I didn't really have to convert this. But now, say you didn't do all this up here, you could have took this 12.73 euros per square mile and used these conversions we figured out and still came up and got your 125, okay? Oh, those are little bitty apartments, y'all. 110 square meters. That must be like a, oh, what do you call that? A
Studio.
studio. Yeah, definitely. All right, so that was like your number 15. So that's another, that was a thinking one. I forgot about that one. Good thing you caught that. And So y'all check this out. Which statement best describes a temperature of 110 degrees Celsius? Hot enough to boil water, since 110 is above the boiling point of water. It's typical of Phoenix in the summer, since 110 C is very hot, and Phoenix gets very hot during the summer. Or it's typical of Antarctica in the winter, since Antarctica gets very cold during the winter. So what do we say on our little definitions about Celsius? What was its boiling point?
Let's see. The boiling point was at 100.
Yeah, so seeing they're saying, well, hell, this is 110, which is above the
Mhm.
boiling point. So the best choice would be A. So 110 C would be a little hot for Phoenix.
Hmm.
Yeah, I forget. I think around the 30s or something is almost equivalent to the 90s. So yeah, they'd be a little hot. All righty, y'all. So I think y'all got enough to play with that. So what y'all do, mess with your 2A, BC homework. You'll have a little bit of support and then a regular assignment. Knock that out. Remember, Monday is a holiday. I will not see y'all Monday. I will be seeing y'all again until Wednesday. So that's sort of why I kept it a little slow in the beginning, because we had this holiday and we had to do all that roster certifying and all that fun stuff. So we're out definitely on Monday.
Yes, sir. Could you show me? I was writing down the answers for, I think it was question 10. I didn't catch the last one.
Number 10. Oh, that was it when I was doing the 10 over 8 over 10 minus 4?
I believe so. Yes, sir.
Yeah. So let's see. Let me share that real quick. So I had me a 10 to the 8 over 10 minus 4. So the trick on this one was, since you're dividing these 10s, you got to subtract the exponents. So your answer is going to be a 10. And then what you got to figure out is, what is 8 minus -4? So it's always the top exponent minus the bottom exponent when you do this, okay? So we said, well, since it's a double negative, that's really going to make that a 8 plus 4. And then 8 plus 4 gave me my final answer of 10 to the 12th.
Okay, thank you very much.
Yeah, they're not too bad. It's just the tricky in this section is you're getting a lot of different type of problems. So
Yes, sir. Thank you.
So they're really trying to hit y'all on a lot of things they think is going to help y'all the rest of the way through the course. So that's why you're just touching a little bit on so many different subjects. But y'all, the one you're going to be happy when you get it solved is that one where I had that wire going around that bar, okay? So just remember, do it like I did. Treat it like you're cutting that bar open, make it into triangles, and use that Pythagorean theorem. All right, so I see no reason for a support. We pretty much went over that support type problems with y'all on a Monday. It has a few of those fractions like I went over. But it wasn't too bad. So y'all got any plans for the weekend?
Yep.
Other than my math?
Yep.
Resting.
So y'all gonna have all your subjects ready to go over the weekend, study up for math, English, and all that fun stuff. All right, so let me see. I got Floyd, Jordan, Tamara, Auxiliary, Aiden, Alyssa, Angelina, Ashley, Jordan, Presley, Tennis, and TR. After this weekend, you'll start seeing the participation grades showing up for y'all. So at the moment, just being on my Zooms with me is getting y'all your participation, okay?
Okay.
And next week, I'll probably start breaking out either next week or the week after, might not on a short week, but we'll start doing some kind of activities online where I make y'all answer and chat and do all that fun stuff. Okay, so what I'm gonna do, I'm gonna stop this recording.